Welcome to Newspresso. Here is the top story in the past 6 hours. The idea that a tiny molecule could carry. The kind of data that will link tomorrow's quantum. Yet that's exactly what a team from the University of Chicago has just shown. And the implications are big enough to stir up a conversation that reaches beyond any one nation's borders. The story starts with a simple truth. For a quantum network to work, it needs to talk to the world's existing fiber optic cables. The optical fibers that bring us the internet today carry light at specific wavelengths. The same wavelengths that would be ideal for quantum signals if we can make them quantum. That's where erbium comes into play. A rare earth element, it naturally emits light. Erbium atoms emit light in the telecom band. It is already used in commercial fiber networks. Scientists turned that property into a qubit, the quantum equivalent of a classical bit. It can both store information magnetically and read it out optically. The experiment was straightforward in principle, but it was technically demanding. Researchers synthesized single molecules of erbium. They were bound to a tiny organic scaffold. They cooled the molecules to near absolute zero. They used lasers to set the electron spin. They set it into a controlled superposition. By shining light on the molecule, they measured the color of the emitted photons. They confirmed that the spin state could be read. It was possible with standard optical techniques. A single molecule could act as a spin qubit. The result was that a molecule could act. It could act as a spin qubit. It also behaved as a photonic qubit, all at the telecom wavelength. Published on October 2 in Science. 1. This breakthrough isn't just a neat laboratory trick. 2. It means the qubit can sit on a silicon chip. 3. The chip powers our computers. 4. It can send single photon messages through fiber cables. 5. It does so without losing the quantum signal. 6. That opens a door to building quantum networks. 7. The networks piggyback on today's infrastructure. 8. They do not require a brand new system. 9. Team led by David Oshalom sees this as a stepping stone. 10. They are working to integrate molecules into devices. The devices are on chip. The original paragraphs remain unchanged. In short, this new erbium-based qubit could be the bridge. Connects tomorrow's quantum computers to the fiber optic world we already live in, laying the groundwork for a global quantum internet. Subscribe Newspresso. Never miss a major global headline.